Hi, my name is Dimitar. I'm a project designer at HOK in London, and welcome to this Life Academy advanced class covering Blender for conceptual architectural design. The goal of this class is to generate a computational building mass. We're going to do this with a series of different workflows, and we're going to put them together into one. So on one hand, we'll use subdivision modeling, for which we need to understand topology quite well. And on the other hand, we'll use Blender's modifiers to get a better result. This is an advanced class, so it is preferable to have some experience with Blender, especially dealing with subdivision modeling. The process is going to be broken down into 4 steps. The first step would be to generate and refine our initial massing. And then we're going to bake our geometry. And then we'll tessellate and use the wireframe modifier for panelization purposes. And the final step is presenting our work. We're going to start with something fairly simple. Let's call that our base mesh. And we start with a plane, we extrude it, and we do a series of operations, and we continuously refine our geometry. Then we add a subdivision modifier, a mirror modifier, and we get to our kind of half-point result. So that's our base mesh. We're going to keep that as is. And then we're going to apply some basic materials. Now, those materials are more for our splitting of a mesh, which comes in the next part, than for anything else. Editing our mesh is simple when we use subdiv. We essentially have a low poly cage, and then we have our high poly subdivided result. This is all followed by step 2, where we apply our modifiers and we split our mesh based on the materials. From this point forward, we're going to use different operations for the different parts of the mesh. In step 3, we'll generate a simple panel and tessellate that on one part of our base mesh, which we want to have as a more solid element. So this is where we'll get into tessellate and tissue add-on, and we'll look at some more advanced elements of how we can nest panels and how we can continuously refine our panelization. Once we have our base mesh, we can go with infinite options in regards to what kinds of panelizations we want to end up with. And our last step is going to be presenting our work. We'll do some basic camera settings, some basic material elements. We'll look at using AV, Blender's real-time rendering engine, and also cycles to generate some conceptual results. Thank you. Now we'll have a little walkthrough of the process within Blender interactively, and we will also get started with our process. So this is the mesh that we're going to end up with by completing the whole exercise in the workshop. And let's take a step back now and sort of see how this is built up. So we start first with our base mesh, which is fairly simple. If we go into edit mode, we see that it has a couple of planes and they're pretty much extruded up. And you would also notice that we're only dealing with half of our geometry at this point. The reason being is that we're going to use the mirror modifier. So the next step is using this geometry and then applying a subdivision modifier. So by applying the subdivision modifier, we can already see how this is starting to slowly get refined. If we go into edit mode in here, we see that we only have our initial points as shown in this initial mesh here. But with subdivision, we still have our base cage, but we're looking at a more complicated result. Right, so now the next step is adding the mirror modifier. And I have a wireframe modifier. This is more for visualization purposes, so I'm going to turn it off. In fact, let's go to solid mode just to see what's going on. So once we put the mirror modifier in there, and we can also take subdivision levels to an extra level. So increase them by 1 in the viewport and also in the render. And now we have something that's starting to look like our final result. All we needed to do at this point is start to modify our vertices and move them around left and right, up and down, and refine that in order to be able to get the result that we were after. So the next step is then applying some materials, and they're very simple. The idea behind this massing is that we have 4 kind of really solid elements, really solid parts within our mesh. Then we have these more transparent corridors per se that run along all the axes of the building. So these blue elements are meant to be much more transparent, and you can sort of peek in there, and that's where all the public space takes part within the building. So circulation, breakout areas, all these kinds of things. And then on the bottom, we have some retail, and that also has its own type of facade. So it also has a different material. And as you can see, this bottom, it's also refinement from the mesh that we sort of start to work with. So this is all within the first step, so step 1. And step 2 is then breaking down that material. So what we did is get this and apply all the modifiers and then split the mesh by materials. So we end up with 3 separate objects. With these 3 separate objects then, we start to have fun and we can tessellate. So that's what we have here. So if I turn this off, which is our tessellation result, and I turn on our massing, you see this is exactly our base mesh that we used for our tessellation result. Now within tessellate there are settings that say that we can only, if we wish to, tessellate only a part that matches the specific material slot, in this case material slot 0. And that's how we still have a massing that's a lot more complex and it has all the other elements, yet our tessellation is only for that element as shown in here, the split element. So the white massing. And we have also added some floors, which let's go into material preview mode. And I'm going to change the class. So the good thing about Blender these days is that we can render both within Eevee and with cycles with pretty much the same material setups, except transparency. And the setup transparency in cycles and in Eevee is slightly different, hence me trying to slightly adjust the material settings of the glass in order to be able to see what we have behind. The panelization within tissue is actually a twofold process. The first process is a very simple panel, so it's slightly directional. I think it's always interesting to have something that has a little bit of directionality into it. And then this panel is used for a very simple mesh with 4 faces. And then we have an extra element, which is this exoskeleton diagrid that we see throughout. Now, within our tessellation, all of the elements are still linked. So if we go to object data settings and we scroll down to tissue and tessellate, and we see that we still utilizes the base and the component. In other words, if I go and change something in here, in fact, let's go ahead and delete one of these. And now selecting our mesh, we go and click refresh. And it takes a little bit of time because we're getting to a lot of poly count now. In fact, our poly is seeing statistics, but they're not too bad. Okay, so once we raised one, you see what happened. And at the moment, I've set tessellate to be random, and that's why diagrids work pretty well, because no matter which direction our panels are turned, we would always have the 2 ends meeting each other. Whereas in random, you can see some have directionality that follows and some then get broken down, which is also an interesting effect on its own right, if that's interesting to you. And if we're not satisfied with the randomness in the way that it's applied at the moment, there are settings to adjust that as well. So what do we need to be able to execute this class in a lot of time? So we definitely have to be pretty comfortable with modeling in Subdivision, understanding how edge loops work and how edge cuts work. In other words, how we get from this result to something like this. So if we start with a blank element, so I'm just going to copy this as a nice base here. We add a plane. Go into edit mode, scale that plane up. And I'm going to expand it in both directions. And then from here, we start to extrude and shape up our element. In fact, I'll do it very simply. We can just do something like this. We delete our faces, the ones we know we don't need. So this is going to be our top and that's our bottom. And then from here on, we're going to start shaping it. So we press Ctrl R to insert an edge cut, a loop cut, and then Alt click that vertex to select, move it around, and then start selecting vertices here. We start to move these around, and if we want to, we can insert another loop cut, scale it slightly, and then start bringing these edges down a lot. So that's our base mesh. What's important now, because we'll be using a mirror modifier, is making sure that the results align on both sides. So for that, we need to understand also object origin point. So, which is the orange dot that lays in here. When we're using the mirror modifier, we have to make sure that the object origin lies along the center point from which we want to mirror. For example, right now, if I add a mirror modifier, you see our geometry is not perfectly mirrored because it's mirrored against that point. So to move our object origin points, I'm going to select this whole loop, right click, or rather Shift S, cursor to selected, go into object mode, right click, set origin to 3D cursor. So now we moved our 3D cursor somewhere in the middle. It doesn't really matter whether it's up or down or high, what matter along. So it doesn't really matter where the origin point is along the y-axis, but it does matter exactly where it is along the x-axis. As long as it's on that plane, we're good to go. So from here, we can continue to refine this by moving elements around in different directions. And once we're satisfied with something, or even if we're not, we can at some point start adding the subdivision surface modifier. And let's change the lens resolution. And let's start moving some vertices. Now that we have a better understanding of what the mesh starts to look like once it's being subdivided. Now it's important to understand how mesh subdivisions work. So, for example, if I create a loop cut here, and let's go to top view actually, I think that'll show it better. So if I create a loop cut here, you see immediately the edges get much sharper, right? Before, if I undo this, the whole shape is much more rounded. And if we add new geometry, new topology, new vertices and edges, everything gets sharper. If I continue to add loop cuts on both sides, the edges get sharper and sharper. So that's why, depending on the kind of result we want, we need to understand exactly where we want to put that extra bit of detail with loop cuts. We don't want to put them everywhere, because if we do, we will essentially end up with a very kind of defined mesh that abides almost by the boundaries of the cage, so it doesn't smooth out the corners. It doesn't interpolate as much. Now, if we go and slide an edge, so if I select this, right click, make sure you're in edge selection. So if I right click, edge slide, and if we move that vertex close to the edge, you see those edges get much, much sharper. And the further away they are, the smoother the result. So if you want to keep a corner very sharp, we put a loop cut there. Now I can insert an extra loop cut somewhere in the middle. And if we go to top view, we see now we have some sharp corners and some that are less sharp. Now, if you want to make this a sharp corner as well, we can either do the same thing. So in this case, we'll be doing a bevel. So we can right click, bevel edges. And essentially we're using bevel here to add new topology. So if I scroll while the command is active with the scroll wheel, we can change the number of cuts that we have. And if we keep them really close, you see this is now starting to look sharp. Now, if we move the vertices around, if we move the edges around on the ground, you see that on the ground it's less sharp. And then because they kind of come together on top, there's a smooth transition between the sharp and the less sharp elements. Now, I'm going to undo this. And we're going to cover a different way to make sharp edges and to modify topology, and that's with edge creases. So if we press Shift T and we scroll with the scroll wheel, and you see that edge turned a different color, and we can also change the edge crease after the command here. So that creates a sharp kind of intersection. There's also another place where that control lives. So if you open the sidebar to item, and there's something called mean crease. If we change that to 0, it appears as if it's not there, and if it's 1, it's to the max. And the value can always be between 0 and 1. Now if we do that to a corner, so I'm selecting this corner loop cut here, and change the mean crease to 1, you see in the corners, it becomes a lot more prevalent. Now this result may be a little bit too sharp, so instead of using 1, we can use something like 0.97. Now this is using all the existing geometries, just having a stronger pull. So in that sense, it works a little bit like knots doing NURBS. As you can see, the topology looks quite different on this side where we didn't introduce extra geometry. Whereas on this side, it's a little bit smoother, it's a little bit more refined in some ways, but there are some costs associated with that. The fact that we have that many more faces because of the extra loop cuts that we've inserted on that side. So what happens with subdiv if we try to open a hole? If we're in mirror mode, if this element is not along the local y-axis, or rather x-axis for this, in this case, then the subdivision modifier follows. And that depends on the stack. So if we do first subdivision, so if we move subdivision first and then mirror, you see none of these elements really meet anymore because it's first doing a subdivide and then it's putting them together. And that's quite prevalent here because this is now the subdivision faces edge, right? So if we turn off the mirror, that's what it does first, right? So this is our base mesh, then we do subdivision, and then we do mirror. On this side, it kind of looks okay, but it really isn't. The only reason why it's okay is because these are planar. So if I move this point around, we can see that we have a sharp edge, which could be a nice effect if that's what you're going for. But for example, here in the middle, where we do want them to meet, they don't. Now, if we put mirror again on top, and we have some issues with the geometry here, I think this point got moved a little too far out. So to put it back in line, let's turn on the snaps, make sure we're snapping to vertex, and now go and hover over one vertex with the gizmo enabled. I'll do that again. So click and hold the gizmo, and now that point is perfectly aligned, right? So with the mirror first, if I turn off both modifiers, we have this, our base geometry, then it mirrors. And as you can see, when it mirrors, it doesn't matter where the mirror is located within the stack, it does try to create two sides to it. So now if we turn on subdivision, then everything is connected. Make sure you turn off your snaps when you don't need them to, because otherwise the geometry starts to turn a little bit funky when you try to snap to vertices. Now the last topic I want to cover before we get started is understanding the user interface a little bit and being comfortable with adjusting it, because we are going to be doing some adjustments. So for example, this is the user interface that we'll be using when we're generating our mass. And the idea is to have multiple viewpoints, multiple vanishing points, that when we do little subtle movements within our base mesh, we can easily visualize those wherever they're needed. So on top, we have different kinds of default user interface experiences. So one for layout, and that's the one that I basically start with the most. Sometimes we can go to shading, for example, if you want to edit materials more, but I usually build my own basic layouts. So to create a new layout, right click and select duplicate, and then if we hover somewhere in between two different kinds of views, right click, and we have either vertical split or horizontal split. So in this case, first we want to do a vertical split. And let's put that vertical split somewhere over here. Let's hide the sidebar. I'm going to scroll with the scroll wheel on the header to get to the end of it and turn off the gizmo types and display overlays. So we have a clean viewport. So from here, we can go and zoom into our object and kind of set a viewpoint. And then we can do the same by splitting this viewport now into two. So right click. This time we want to do a horizontal split. And I'm going to look at it, for example, from this side now. So you can imagine if our base mass was here, in fact, why don't we move those over here? And I'm going to duplicate this to show these examples. Let's put that over there. View selected. And I can, because I know it's selected, we can go over here. So now, if we start moving something in here, we can immediately understand the impact of what that means in regards to the different views that are important to us, to our experience, and to the mass that we want to create. And that could be any kind of vantage point. You know, we can make this as complex or as simple as we want to. I've had instances where I have 2 rows of windows open, 3 or 4 windows in each, so 4 or 5. So how many is that? That's more than 4 or 5. 6 or 7 views all at the same time with different views: aerial, bird's eye, human perspective, worm's eye, to be able to generate the massing that I was looking to generate. Thank you for making it to the end of this video, and can't wait to see you in the full course.